Hey everyone, it's Tiny Tom Logan back with another video for you. Now, I don't normally do previews with two boards at the same time, but I kind of thought this would be a really good way of me being able to show you how to keep an eye on some of the things with B550, in that the way the manufacturers are able to use the PCI Express lanes that are available to them in slightly different ways. And these boards, although they do look very similar, have gone about the storage and the PCI Express side of things in a very different way. And I thought it'd be really nice for us to see these two options side by side. Now, I am going to do a full look around the board style preview, and then at the end I will talk to you about the PCI Express side of things and the way the block diagrams and the way things are laid out with the two side by side. Now, at the moment, because of NDAs, I'm not allowed to talk about price, and I'm quite clearly not allowed to talk about performance, but you're going to get a good feel for what's coming up with B550, and also why I'm personally more excited about this than the launch that we've just done. So, I'm going to start with the Pro, and the first thing that I will say to you is around the top edge here, there are 12 plus 2 power phases, but they're doubled up from 6. I've not been told any of the specifics from Gigabyte yet about what components have been used, amperage ratings or anything like that, but compared to the Master, this is obviously the cheaper of the two boards. So 6 doubled up into 12. You can see that we've got the fine fins on the right hand side, which is a really nice good way of keeping everything cool, because it's massive surface area. But you can see across the top they've gone for the normal chunk of aluminium, which is obviously cheaper. Otherwise, when we look around the board, you can see you've got a single 8-pin at the top here. It's not shielded or anything, but there is a a fan connector there. You get a couple of CPU fan connectors here. Up here you can see you've got addressable RGB and then normal RGB. We come down the side of the board though, what's actually quite nice is there are 3 fan headers there. As we do come down, you can see that you've got a Thunderbolt connector, nothing in the box, it's an add-on, it's a cheaper board, don't forget. 6 SATAs, then you get your front panel connectors here. USB 3.2, wonder how I knew that. You get a couple of USB 2s here. Amp up audio down here, some nice capacitors, Japanese capacitors, 9mm capacitors. And then when we go round to the back of the board, you get an onboard HDMI, but do remember that you need an APU to be able to use that. Most of the CPUs out there don't have integrated graphics. Load of USB 2s. We do get some super speed USB 3.2 Gen 2s as well, which is a nice one. You get Type C, but also for a board like this, what's quite nice is the fact that you do get 2.5 gigabit in Ethernet as well. Now, at this point, I would normally talk to you about PCI Express, but what I want to do is cover the two boards side by side in a sec. So we'll move on to the Master. Now, this is actually a Big Daddy VRM version, because I don't know whether they're doubled or parallel wired yet. I would say parallel wired because that's probably the best way, but you can see here that 16 phases, 70 amp power stage. It does say direct, but I don't know whether it's got a 16 phase controller or not, whether, like I said, there might be parallel wired into 8. I don't know, I'm going to have to clarify with Gigabyte about that. Because if it's got a 16 phase controller, I'd be expecting the price to be enormous, especially with these 70 amp power phases as well. That's kind of TRX 40 Threadripper kind of level of power delivery. So it could swing either way, I don't really know, but still 16 phases is still rather mental. And you can see that they've both of the heat sinks have those fine fins for massive surface area, lots of cooling. You can also see that you get a section of it over here as well. If I move the light, you'll be able to see it better. There we go. It's actually a good looking power delivery area. I quite like this, and I like the fact that Gigabyte kind of led the way with bringing the old style finned heat sinks back as well, because we were at the limits of what was capable with the hunks of aluminium that everyone was using. Anyway, top corner, you can see you get an 8-pin shielded main power connector and then a second 4 fan header here. When we come across, you can see that you get 2 more CPU fan headers, and then again you get the RGB addressable and the normal 4-pin RGB. PCI poster readout coming down, very similar to the Pro. You get another 3 fan headers, again very similar to the Pro. Thunderbolt connector, it's not in the box. 6 SATAs. Front panel header connector again, USB 3.2 Gen 2. 2 more fan headers. Get the RGB again down here, so you get an addressable and a normal. Then into your audio, and with the amp up audio you can see that it's got another shield across that as well. There's another fan header hidden over here as well. Round the back, again very similar to the last layout, but with the audio on this you can see that you've got gold plated connectors up this end, and you get the inclusion of Wi-Fi and Bluetooth, and there is an antenna in the box as well. But as I said, talking about PCI Express, okie dokie. So PCI Express, it does get a little bit complicated with the 2 boards as well, because they are very different. Now, just to remind you, the CPUs with the 3000 series Ryzen stuff, PCI Express 4, and there's 24 PCI Express 4 lanes available on the CPU itself. Now, you get 16 of those for the graphics, and then normally what happens, or what did happen with X570, is you add then 4 for an M.2 drive, and then there was 4 to interconnect to the X570 chipset. What happens with B550, however, is you do still get 4 for your NVMe, and most of the boards that I've seen so far, that's normally the top NVMe's on the board as well. But the interconnect to the chipset is PCI Express 3. Now it still uses those PCI Express 4 lanes on the CPU, but it's in a PCI Express 3 mode. So you kind of, for want of a better term, and I hate using it, but it's kind of bottlenecked into the chipset. And then the chipset does have some PCI Express 3 lanes as well. So the easier one to talk about is the Pro, because with the Pro, top NVMe is PCI Express 4, bottom NVMe is PCI Express 3, and that is because that NVMe is wired into the chipset. Also, the 2 lower PCI Express slots on this board as well are PCI Express 3 as well, wired into the chipset. Because of that, what it does mean is no Crossfire or SLI is available on this board at all, because you would need it to go into the CPU to be able to access that properly. So these are basically add-in cards, like you could put, let's say, a Wi-Fi card on it because it's not on the back, or a sound card, for example. Any of those kind of expansion card kind of things, but not for graphics. So you only have a single slot available for graphics, which recently, to be honest with you, most of us have gone single big graphics cards because it's almost like they have been phasing SLI and Crossfire out. Now, with this one, it's the same kind of deal with the PCI Express 4 with the like the main slot. Single graphics card only, because the 2 lower slots are wired into the chipset. So those 2 lower slots wired into the chipset, PCI Express 3. This one wired into the CPU, PCI Express 4. This is when things get very complicated though, because the top NVMe is wired to the CPU, and that's fine. The lower 2 are actually wired into PCI Express 4 as well, but if you use either of these or both of these, the graphics card then gets stepped down to an 8 times lane, and then the bandwidth then gets divvied out to these. So you still only get 16 lanes in total, but if you use a second or a third NVMe, it will go down it will flip the bandwidth down. That also does mean if during your building process you think to yourself, I'm not going to put my NVMe there because it's right at the top of a hot graphics card, so I'm going to move it down into that bottom one, that you are then going to be capping your bandwidth of your graphics card down to 8 times. Now with most graphics cards, it's not going to be a problem. And I doubt whether you're going to be buying one of these boards and then chucking a 2080 Ti in it, but it's worth noting. It's something that might be more useful further down the line if we ever get some mental graphics cards that actually start to saturate even PCI Express 3 bandwidth, because at the moment we're nowhere near that. But anyway, the point is there that things do get a little bit more muddy with this board. The only good side of this board is that you don't have to worry about any shared lanes going on, because one of the things I did forget to mention is with this board, and this is a bit of a boo-boo of mine, I should have said this earlier, if you do use the PCI Express 3 NVMe here, this lower slot then becomes completely redundant, or at least that's the way that the block diagram reads. I will get a definite answer from Gigabyte for that. The only reason why that would ever become a problem would be for like a system integrator, or for those of you at home that might end up upgrading over time and think, oh, I can add that in. You might buy yourself a RAID card or something. You're never going to know. And then, like I said, that slot then becomes in question because there's no switch there, and it does say on the block diagram, it does say or, which basically means you can have the NVMe or that slot. So for me, it's one or the other, not both. Whereas the block diagram on this one, when we were talking about the NVMe's, you could see that they were all in there kind of together. So B550, a couple of nice boards from Aorus. You might wonder why I said that I was actually more interested in this. Well, to be honest with you, with this, it's bringing PCI Express 4 down into the kind of more of an affordable price bracket. Because with the X570, the boards were all, let's face it, really expensive. Now, I don't think that the Master is going to be cheap, and I actually think this is probably going to be a bit of a grey area, and I think the price is probably going to bridge some of the lower-ish end X570 boards, mainly because of that power regs. So this could be the sort of board that you put a 3900X on, for example, or a 37 or a 38, whatever, big graphics card, NVMe in there, but then you're not going to be spending, you know, the normal version of this X570 was, I think it was high 300s, maybe even £400. So with this, I'd expect it to be cheaper. So you can kind of, it depends whether you want all that PCI Express 4. So you could end up saving a few £100, maybe 150 quid. I don't know. I'm not talking about price, AMD. I'm guesstimating. You could save money and get this board, and then you've got your system. Whereas this, I kind of end up seeing this board being something that you've either got a really high-end board for your 3300X, or maybe you go in with something kind of healthily for your 3600 or even 3700X. So they've both got their markets kind of fairly well put. And obviously now, the lower-end CPUs that we had from AMD, you're not then instantly then going to be going looking at B450 or older X470 boards. You can now get like the newer up-to-date boards with USB 3.2 Gen 2 and Wi-Fi 6 with this one, for example, and 2.5 gig Ethernet. So you get all of the most up-to-date technologies, but a more accessible price point, or at least that's what we're hoping. And I don't know yet because I've not been given any official pricing, although there has been some news put on the OC3D website about rumoured pricing, but weirdly, I'm not allowed to talk about that in videos. Anyway, so a couple of good boards. I'm actually really looking forward to getting my teeth into these and testing these. And just one for the regulars, if you are going to come back, I am going to be testing all of the boards with 3900X. And that might sound weird, but that is because then I can compare all of the results directly with all the X570 tests that we did before. And that will also mean we'll be able to see the difference between like the VRMs. Yes, okay, we are probably going to find some VRMs that get really warm with the 3900X. But with something like this, you'll also know that you might be a little bit future-proofed with it and that it might be able to cope. So by stressing these boards much more, it's not trying to, well, it is trying to find a weakness, but it's also about delivering information, because let's face it, with these, there is a lot of upgrades that you can do. So you might end up buying one of these, and then in a couple of years' time, you end up coming back, finding my video, realised I've been an idiot, tested with a 3900X because your mate's just about to sell one for 150 quid, and you don't want to go out this weekend, so you're going to buy a 3900X and stick it in your board. Deep breaths. Yeah, so that's my thoughts. I'd love to hear yours underneath. This is the tiniest one. Obviously the vitamin D is doing me some good because I feel quite good today.